Hey everybody, welcome back. This is Chapter 2, Part 2 for Chem 104. So if you have not watched Part 1, stop this one, watch Part 1. You need Part 1 in order to understand Part 2. Part 1, we went over the first 5 sections of Chapter 2. And in this video, we're going to finish up with Sections 6 and 7. So if you haven't watched it, you need to. And if you don't understand parts of Chapter 2, the first part, go over it again, because we're going to be using all of those things to finish out the chapter. Here we go. The first part that we're going to cover is problem solving using unit conversions. So we talked about equalities and writing conversion factors from those equalities in section 2.5. So again, you need it. This time we're going to use those conversion factors to change from one unit to another. So whenever you're solving problems in chemistry, you have to have some kind of a method, okay? And in this case, we're talking about converting one unit to another. And usually, you need more than one conversion factor to change from one unit to another. So in order to do that, the first thing you need to do is identify the given quantity units. So let's say that the problem tells you that someone ran 573 meters, and the question is asking you, how many feet is that? Well, you identify the given quantity units. So we're told about the number of meters. Then you have to determine which units do you need? What's the question asking? So in this example, we're asking about how many feet. Then you identify the conversion factor or factors that you need to get from where you are to where you're going. So in this case, it would be, we have meters. How do we get to the number of feet? And you would have to figure out what that conversion factor is. So let's do an example. A person weighs 164 pounds. What is the body mass in kilograms? The first thing we have to do is identify what we're given. We're given 164 pounds. What do we need? What is the question asking for? We're asked to take those 164 pounds and convert to kilograms. The next thing we need is to figure out what our conversion factors are. And so I've given you the equality, 1 kilogram is equal to 2.20 pounds. So from here, we can write our two conversion factors. Remember, conversion factors are like fractions. So you take one of the values, we'll start with the 1 kilogram, and write that over the 2.2 pounds. Then the next one, you just flip that conversion factor over, and there you have it. You've got two conversion factors. And we'll label this one as well as the equality, so that you get used to that terminology. Because when you see it in a practice problem, you need to understand what you're being asked for. So we have an equality. We wrote two conversion factors. Now we need to figure out which conversion factor we need. And we're trying to get from pounds to kilograms. So when we do the math, we're going to need to cancel out the pounds and be left with kilograms. So for that, we're going to want to use the conversion factor that I just circled. Now let's set it up. 164 pounds times our conversion factor. I like to be colorful with this because then it helps it to stick. So we circled it in this powder blue. So we'll write it in powder blue so that you make the connection. Now, before you touch your calculator, make sure that your units cancel to give you the unit that you need at the end. In this case, we're looking for kilograms at the end. We have pounds at the top and pounds on the bottom. Those cancel, and we're left with kilograms. You go back to your little plan over here to say, okay, am I looking for kilograms? Yes. Now you can proceed to touching your calculator. But notice how we didn't do any kind of number or anything. We were just writing out our plan. What were we given? What do we need? What else do we know? Writing our conversion factors, writing out the calculation we're going to do, checking through our units, and then we finally touch the calculator. So don't just pick up your calculator and start pushing buttons, okay? You want to make sure that you know what you're doing and that what calculations you do will actually give you the right answer. When you put that into your calculator, you're going to say 164 divided by 2.2. And your calculator is going to tell you a number with a bunch of digits. We need to figure out how many sig figs we need to report. So in our setup here, we have this 164 pounds, which is a measurement, and it has 3 sig figs. Our equality, while it is defining a relationship, part of the relationship is a measurement. And the part that is a measurement is the 2.2 pounds. So we have to look at how many sig figs that has. That also has 3 sig figs. That means our answer has to have 3 sig figs as well. That means we're going to be looking at the 5 to round that for our last retained digit. Look at the 4 next to it to see whether we round up or we drop everything. 4 is 4 or less, so that means we're just going to drop everything and report it as 4.5. So this is our sig figs answer. Are we done? No. 74.5 is a number, but it's naked. I don't like naked numbers. We're trying to figure out how many kilograms 164 pounds is. So if I just said 74.5, that doesn't tell me what unit. So write kilograms. On your chapter check-in, units are absolutely going to be worth some credit. So if you have the number right, that's great, but you need to have units. I will take off a half a point because you don't have units. Now on the exam, it's going to be multiple choice. So you won't have the option to leave off the units. You're welcome. But for the chapter check-ins, I want to make sure that you actually know, okay, I need to put this down as my unit. Okay? So those are all the steps for using an equality, writing conversion factors, and then doing an actual unit conversion. Let's do another one. So this is a learning check problem, but I'm going to walk through it again just to make sure that you understand how to do it. So right now, we just have a rattlesnake is 2.44 meters long. I don't like snakes, y'all. I am not from North Carolina. And when I was told that there are all types of poisonous snakes and stuff around here, I was like, I should have rethought my decision. But I'm here now. How many centimeters long is the snake? What are we given? We got this dat blasted snake that is 2.44 meters long. What do we need? We need to know how many centimeters this is. So we're going from 2.44 meters to some number of centimeters. Now notice there is no equality given here. So you need to use your chart, or in an exam setting you may be given some options for what your equality is. But you need to know that if I have 1 meter, Knowing centi means 10 to the minus 2, there are 100 centimeters in 1 meter. That's your equality. Again, this is from the first part of the Chapter 2 lecture in the previous video. So if you're like, what? I'm down for equality, but I don't understand, make sure you rewatch it and have that table handy that I tell you so that you can practice writing your equalities. Now that we have our equality, we need to now write our conversion factors. It's the simple part. But you have to make sure your equality is right, or else these conversion factors will not help you. So we have 1 meter over 100 centimeters and 100 centimeters over 1 meter. Conversion factors. Boom. Now we have to figure out which one of these we want to use. We're trying to go from meters to centimeters. So that means that we want to cancel the meters and have the centimeters on top. So we're going to go with the 100 centimeters on top and the 1 meter on the bottom. Now let's set up the problem. 2.44 meters. We're going to multiply by, not green, give me blue. Multiply by our 100 centimeters over 1 meter. It's our conversion factor. Don't touch your calculator. I want you to first make sure your units cancel. We've got meters on the top and meters on the bottom. You have to have one on the top and one on the bottom in order to cancel. And what you're left with is centimeters. You double check, is that what I'm looking for? Yes, I want centimeters at the end. Now you do the math. 2.44 times 100. Your calculator is going to tell you 244 centimeters. You have to make sure that you're reporting the right number of sig figs. We've only got the one number, which is 2.44 meters, and there's 3 sig figs there. Our answer has 3 sig figs, so we're good to go. But don't assume. Never assume. Make sure this makes sense. I would recommend you can change the number, or you can flip it and say, okay, let's say that I have a snake that is 112 centimeters long. How many meters is that? So you can kind of do self-practice to make sure you get it. We will also do plenty of practice in class. You will need to remember how to do these kinds of conversions, and you're going to need to understand just the concept of canceling units to do a calculation, especially when we get to the later chapters, like chapter 7. So don't remember it for the exam. You got to remember it for the long haul, okay? So we were just using one conversion factor. You can use more than one, and sometimes you have to. So when you set up these problems, you're going to have one factor followed by the other, and you arrange them so that you cancel all the units and you're left with what you want at the end. So that's what all this text is. So let's try one. A doctor's order prescribed a dosage of 0.150 milligrams of Synthroid. If tablets contain 75 micrograms of Synthroid, how many tablets are required to provide the prescribed medication? So this is a real life thing. You have to have a certain dose, And the tablets only come in a certain amount. So you have to be able to prescribe, take this many times a day, or all at once. So this is real life, y'all. What are we given? We know that the dose required is 0.150 milligrams, and the tablets contain 75 micrograms. Okay? What do we need? Well, we need to know how many tablets. To make up that 0.150 milligrams. So it doesn't seem like we have enough to write an equality, but we actually do. The part that we're going to write an equality about, we're certainly going to talk about these tablets. And then we have to do something to relate milligrams and micrograms. So let's start with the easy one first. One tablet is equal to 75 micrograms. So that's one equality that we know just from the problem. But how do we relate micrograms and milligrams? Well, thankfully they're both grams, so that means that we can go from one to the other. We know that 10 to the third grams is equal to, that should be milligrams. Is equal to 1 gram, and that's from the table. And 10 to the 6th micrograms is equal to 1 gram. Well, we can kind of smush those together to write another equality. If you have 1,000 milligrams, you also have 1,000,000 micrograms. Now we need to write some, I'm making all the mistakes right now. Let's not. I'm getting ahead of myself because I'm excited. So that's equality number 1. Here's equality number 2. We need to write some conversion factors. We can write 2 for each. I'm going to abbreviate tab for tablet. And then for our second equality, we can write 10 to the third milligrams over 10 to the 6th micrograms, and we can flip it. So we're starting with this number of milligrams. Let's first take that number of milligrams and convert to let's try to write it here let's write it on top. Convert to micrograms. So we're going to use the second equality first. We're trying to get rid of milligrams and instead go for micrograms. we want to get micrograms on the top. So that's what we're going to fill in here. 10 to the 6th micrograms on the top, 10 to the 3rd milligrams on the bottom. And we're not done yet. We still have to go from the number of micrograms to the number of tablets. So right now we have micrograms, and we need to make sure that our ending unit is tablets. So we're going to want the tablets on top. Now let's make sure that our math makes sense. We've got milligrams on top and milligrams on the bottom, and we're canceling that out to figure out what our dosage is in micrograms. Then we're going to cancel out the micrograms to be left with the number of tablets that's the equivalent dosage. Make sure that that makes sense. We have to get to the number of tablets, not the number of micrograms, but the number of tablets. So when you're putting this into your calculator, you're going to take 0.15, and you're going to multiply that by 1,000,000, divide by 1,000, and that should give you the number of micrograms. Then you're going to take that number and divide by 75. Your calculator answer is 2, okay? But we need to go and look at the problem to see what do we need to do in terms of sig figs. We have the dosage, which has 3 sig figs, and we have the amount of medication that each tablet contains. That has 2 sig figs. So our answer needs to have 2 sig figs. So we have to add a 0. 2.0 tablets. That's using 2 conversion factors to convert from one unit to another. We'll do more examples of this in class as well. Let's do another one here just to make sure you understand it. So we're going to take 1.4 days and convert that to minutes. So what are we given? 1.4 days. What do we need? Well, we're going from those 1.4 days to some number of minutes. So we need to have some equalities here. Now these you should kind of know just because you've been a human living on Earth for a while. So we have to go first from days to hours, okay? If we have 1 day, how many hours is that? It's 24 hours. So your conversion factor should be 1 day over 24 hours and 24 hours over 1 day. Not rocket science. You know how many hours are in a day. Once we have those hours, you have to go from hours to minutes. Now I'm sure you're looking at how many minutes are in the YouTube video, trying to figure out, can I watch the whole thing? Can I put something on in the background? It's all right. So how many hours? We have 1 hour, We have 1 hour, we have 60 minutes. So that's something you shouldn't have to look up. For your conversion factors, you just make two fractions. So 1 hour over 60 minutes and 60 minutes over 1 hour. Now we start setting up our problem. We've got 1.4 days. And we need to use two different conversion factors to get there. Let's make some decisions. We're trying to get from days to hours with this first bridge. So we want to have hours on top. The next piece, we want to go from hours to minutes. That means we're going to want minutes on top. So just from looking at it, you know you're going to end up with a big number. And that makes sense because minutes are a smaller slice of time than days. But we also want to make sure to do our unit check. So you go through, say, okay, my days cancel, and I am left with hours. Then my hours are going to cancel, and I'm left with minutes. Great. Now you can touch your calculator. I know you've been itching to touch it. Now you may. Your calculator is going to tell you a number. That doesn't help you because you need to report a certain number of significant figures and you need to know where you're going to round. So when looking at all of the numbers that we use, the only one that's a measurement is the 1.4 days. The other two equalities are definitions and they're exact numbers. So you don't have to worry about the 24 or the 60 when it comes to sig figs. We're just looking at the 1.4 days. And that has two significant figures. This means for our calculator answer, we're going to be rounding that 0. You look to the right of it, there's a 1. 1 is 4 or less, so we're just going to drop everything. But we can't just write 20 because that's 20. We need to add some placeholder zeros. So 2,000, and then what are our units? Minutes. The other way that you can write this using scientific notation and showing the number of significant figures, because 2,000 only has one sig fig in it. So we have to rewrite it in scientific notation. That way, we have 2 sig figs, which is what's required for the problem. Make sure that makes sense. Let it simmer. Why we had to write it in scientific notation. And if that makes sense to you, then move on. If it doesn't, take note of that. Ask about it in class. We'll be going over plenty of examples. So let's link up what it is that we talked about to health. I know everybody isn't a nursing major or in psychology that's taking the course, but we've all been to the doctor, and we all care about health to some degree since we want to be healthy, right? So, in talking about toxicology, the dose is the difference between a poison and a cure. So you can take a medication that will help you, but if you take too much, it can kill you. So you got to be careful. So you have to look at the danger of different substances. So all these medications that are available over the counter or prescription antibiotics, all those kinds of things, there are risk assessments made where they figure out, okay, how much can we give an animal before they start experiencing these negative side effects or before they die, which I know it's a little bit morbid, right? Poor animals, poor lab rats. Sad face. But, I mean, low key, if it's got to be them or you, maybe it's selfish as me, but I'm going to choose me. So, God bless the animals in the labs. Anyway, one measure of toxicity is the LD50 or the lethal dose. And that's the amount of substance or the concentration of substance that causes death in 50% of the test animals. So on the next slide, I got an example, okay? So coffee. I haven't had coffee in years because I've been pregnant or nursing for like 4 years, okay? And caffeine just don't do me right. But when I was in college, oh, I imbibed the caffeine and all the energy drinks and stuff, which are terrible for your body. Caffeine, it can give you that little bit of wake up and whatever else, but it can also kill you. So there is an LD50 for caffeine. It's usually measured in milligrams per kilogram, so milligrams of whatever substance per kilogram of body mass. Or for some medications, it's in micrograms, if that's how little it takes to kill some animals, okay? And this is a table that has just some common substances that we know about. So stuff like table sugar, which isn't going to kill you right away, but there is type 2 diabetes. Hello. But there are other things like table salt that you wouldn't necessarily think about. Ethanol, which if you're under the age of 21, you shouldn't be touching anyway. And then there are some over the counter medications like aspirin. You might get codeine or oxy as painkillers if you've gotten teeth removed or anything like that. All of these things have an LD50. And the more toxic something is, the lower that LD50 is. So these pesticides, cyanide, that is absolutely a known poison. Like all of these things have a really low LD50 because it doesn't take very much to kill a person or an animal, okay? So understanding, especially if you're in the medical profession, how to take an LD50, how to make prescriptions that are correct for the person so that you're not giving them too much, that you're in that window of efficacy is really important. So we covered kind of the crux of chapter 2. We built up a lot to be able to do those conversions. Now we're going to talk about density. And we're going to do some more conversions using density. But first we're going to introduce what density is, just the concept, how you measure it, and those kinds of things, before we start doing some math. So this is just a table of common substances and their densities. You don't need to memorize this. If you're doing a problem, you're going to get the density as long as it's not what you're solving for, okay? So if you need to know the density of a solid or a liquid at whatever temperature, that's going to be provided for you in the problem. When you're calculating density, you're looking at the mass of the substance divided by the volume of that substance. And if you're talking about solids, you're going to use grams per centimeter cubed as your units. Whereas for liquid, you're going to use grams per milliliter. And that's simply because the volume for solids, you report in centimeters cubed, and for liquids, we use milliliter. They're the same thing, but it's just convention. For gases, you're going to use grams per liter, okay? So note, a milliliter and a centimeter cubed are the same. It's just convention for what we use for solids versus liquids. But let's say that you have a solid. You can't necessarily measure the dimensions and do a little multiplication to figure out what the volume is. Sometimes the shape is kind of irregular. So you're going to need to determine the volume of your solid without actually measuring, getting out a ruler or something and trying to measure it. So the mass is easy. You just pop it on a scale, ding, and you're done, right? But for the volume, you can use something called volume displacement, which I'll talk about more on the next page. So to determine the volume, you're going to take, in this case, our example is this zinc here, and you're going to have some water or some other liquid that you can displace. So you're going to take the zinc, put it into the graduated cylinder. Notice that the water level rose. So before you had the zinc in there, it was 35.5. You put in the zinc, and now all of a sudden, your apparent water volume is 45 milliliters. If you subtract the difference between the final level and the initial level, then you will end up with the volume of the solid. So that is volume by displacement. Once you have that, and you take your mass from the scale, then you can calculate the density of, in this case, zinc, but whatever solid you have. And you divide the mass by the volume. Notice how there are two sig figs in the volume, because when we did our subtraction, we could only keep up to the 10th place. That's all we had. So that gave us two sig figs. And our mass has 4 sig figs, but our answer only has 2 sig figs. So remember sig figs when you're doing this, and don't forget your units. For density, we're talking about grams per centimeter cubed for a solid. So let's do a problem together. Well, it's sort of together. You're watching me do a problem. Not exactly the same, but we'll do some together in class, I promise. So what is the density of a 48.0 gram sample of a metal if the level of water in a graduated cylinder rises from 25 milliliters to 33 milliliters after the metal is added? We have this lovely picture here. So at first we have 25 milliliters. You put in your solid or your object, and the level is now 33. So what are we given? We're given a mass of 48.0 grams, and we're given a volume indirectly, which we can determine by subtracting the two water levels. So the final water level is 33. The initial water level is 25. You do that math. Don't be ashamed if you need a calculator. It's okay. Sometimes mental math don't be working right. Remember to use sig figs here. So your calculator is just going to tell you 8. But you need to remember that you need the 10th place too. So we're going to call this centimeters cubed, okay? Because milliliter, centimeter cubed, they're the same thing. What we also know is that density is equal to mass divided by volume. What we need is the density. So all we have to do now is take the mass from the problem and divide by the volume that we found. the mass is 48.0 grams. The volume is 8.0 centimeters cubed. You do that math, your calculator will just tell you 6. But we need to report that with the right number of sig figs and the right unit. We've got 3 sig figs in the mass and only 2 sig figs in our volume. So we need to add one placeholder 0 like that with a decimal to give us 2 sig figs. And then grams per centimeter cubed as our units. So remember, when you add that decimal point in the 0, it is measured. So that gives us 2 sig figs. We can use density to actually solve a problem and figure out the mass of something or the volume of something. So we can use density as a conversion factor, just like we did the conversion factors going from, meters to centimeters and things like that. So we can use density as a fraction. So it's going to be, for example, 5 grams, for 1 centimeter cubed if your density is 5 grams per centimeter cubed. So this is an example of a conversion factor. You can also have 1 centimeter cubed over 5 grams. So those are 2 conversion factors from one density. Let's do a problem. John took 2 teaspoons of cough syrup. If the syrup had a density of 1.20 grams per mil, and there's 5 mils in 1 teaspoon, what is the mass in grams of the cough syrup? So what are we given? We're given a density, which is 1.20 grams, and I'm going to write it out for 1 mil. I'm going to write it out like a conversion factor. And that reminds me that, oh yeah, I can use it as a conversion factor. We're also told that there's 5 milliliters in 1 teaspoon. That's an equality. So we can make more conversion factors from that too. And we're going to need it because John took 2 teaspoons. So we'll call that the dose. Let me erase that. The dose that John took was 2.0 teaspoons. What do we need? We need the mass of the dose. Not just 1 teaspoon, 2. So we've got density, and we've got an equality that tells us how many mils are in 1 teaspoon. So let's go ahead and write some conversion factors. So for the density, we already have 1.20 grams for every 1 milliliter. And we can flip that around to put the 1 milliliter on the top and the 1.20 grams on the bottom. So that's a way for us to go from volume to grams. That's what we're trying to do here. And overall, our plan is to go from the number of teaspoons to the number of milliliters and from there to the number of grams. So that's our plan. The other equality that we have is the 1 teaspoon equals 5 milliliters. So let's write our conversion factors. And this is the part where we're going to go from teaspoons to milliliters. Let's figure out what we've got to do. So let's start setting up the problem. We're starting with 2.0 teaspoons. That's the dose. And we've got to use 2 conversion factors to get from teaspoons to the number of grams in that dose. The first thing we're going to do is figure out how do we get from teaspoons to milliliters. We want to get rid of the teaspoons, so that's got to be in the bottom, and we got to have our milliliters at the top. So let's fill that in. Next, we need to go from those milliliters to grams, and for that we're going to use our density as a conversion factor, and we have to choose the one that's going to get rid of milliliters and leave us with grams as our final unit. And that's going to be the one with grams on the top. Before you touch that calculator, make sure your units are going to cancel. We cancel the teaspoons, and we're left with milliliters. Then we cancel the milliliters, and we're left with grams. Is that what we're looking for? Yeah, we're looking for a mass in grams, as it says in the problem. So we should be good to go. Now you can touch your calculator. You're going to do 2 times 5 times 1.2. Your calculator is going to tell you 24. But that doesn't give us units, and it certainly doesn't give us sig figs. So let's look at what we've got. We've got a density that has 3 sig figs. We've got an equality that relates teaspoons to milliliters. So one of those is measured, okay? And that's only got 1 sig fig. Then we've got the dose, and that's got 2 sig figs. So if we're calling the 5 milliliters a measured number, then we have to only go with one significant figure here. And we can write that as 20 and make sure that we have our units for grams. If we're calling that equality a definition, then we would use 2 sig figs, and our answer would just be 24 grams. Now, we're not going to make it that confusing for you to have to figure out, okay, is this equality a definition, or is it something that I need to make an exception for? So I'll try to be very clear about that. But I wanted to show you both ways, just to show you how different the answer can be if you go with one significant figure versus 2. So that's using density as a conversion factor. The final concept that we're going to talk about is specific gravity. Specific gravity is a relationship between the density of a substance and the density of water. So it's a comparison. So it's calculated by dividing the density of your sample by the density of water, which at 4 degrees Celsius is 1 gram per milliliter. and it does not have units. So no units. Your specific gravity has no units. So if you have a substance with a specific gravity of 1, that means that it's got the same numerical value as the density of water, right? Because what you're doing is you're saying your specific gravity is 1, which is equal to the density of your sample over the density of water, which is 1 gram per milliliter. And if you solve that, you better get the density equaling 1. So if your specific gravity is greater than 1, then that means that the density of your sample is greater than water. And if your specific gravity is less than 1, it's the opposite. The density of your sample is going to be less than 1. Or, well, yes, less than water, but it's also going to be less than 1. So remember that concept as well. If I tell you what the specific gravity is for a substance, you should be able to tell me whether or not the density of that substance is going to be greater or less than 1, just based on what its specific gravity is. The last slide in all of these chapters is going to be a concept map, and that's a visual representation of the different concepts that we talked about throughout the chapter and how they're related. So overall, we talked about chemistry and measurements. We started by talking about measured numbers. We talked about significant figures, how we round those, and sometimes we have to add zeros in order to have the correct number of significant figures. We talked about the different types of measurements: length, mass, volume, all of these. And we talked about the different prefixes and the units so that we can convert back and forth. And to do that, we need to know how to write equalities between 2 units, and we need to know how to write conversion factors, which are those fractions that we can then use to solve problems to convert units. As a side note, we also address density, which is looking at 2 different types of measurement, mass and volume. And we learned how to use density as a conversion factor to solve other problems. Finally, we ended by talking about specific gravity and how that is a relationship between the density of a sample or substance and water, and kind of what to expect if you have a specific gravity that's greater than 1 and less than 1. So if any of those topics sound unfamiliar to you, then you should go back and rewatch or look at your notes. If you have access to the textbook, look at the textbook. Make sure that all of those things are at least familiar to you. All of your Chapter 2 stuff, at least some of it, is going to be due on September 6th. So the homework for Mastering Chemistry and the quiz and everything, that's split up. It's split up a little bit. So that first part of the Chapter 2 homework, you should be able to do that by September 6th. And the quiz, you should be able to do by the following Sunday. So we're going to split up talking about Chapter 2 between this upcoming lecture time on Tuesday, and then we'll finish up by doing a few more problems if need be, and then covering Chapter 3. So if you have questions, make sure you take note of those and bring them to class on Tuesday. We'll do practice problems, I'll address your questions, and make sure that you're ready for the homework. Alrighty, that's all I've got for you. So I'll see you in class.